name is Amirul Husni. Let's dive into the foundation of all mathematical reasoning, which is logic. It's integral to how we form valid arguments and prove mathematical statements. The laws of logic are fundamental principles that guide our logical thinking. They ensure consistency in how we approach mathematical proofs and problem solving. Today, we'll touch on some essential rules. The law of identity, which states that an object is the same as itself. The law of non-contradiction, which asserts that contradictory statements cannot both be true. The law of excluded middle, which claims that a statement is either true or false with no middle ground. The law of double negation, which shows that a double negative results in a positive. This principle form the backbone of logical reasonings, helping us to construct clear and convincing arguments. As we explore this further, consider how they apply to your understanding of logic in everyday problem solving.
We move to the description of concept, which is laws of logic. Usage of concept of logical equivalent, tautology, contradiction, and also various lists of rules for algebra proposition. For manipulating logical, which are crucial in constructing valid agreement, proving problems, and solving problems.
There are 5 basic logical connective. Firstly, let's look at negation. Negation is a logical operation that reverses the true value of a statement. It is represented by symbols like negation or the word not. From the truth table as stated in the slide, for example, if a statement P is true, then not P is false. And if P is false, then not P becomes true. So now, let's move on to the conjunction. Conjunction means both statements must be true for the result to be true. It is represented by the symbol conjunction or the word and. From the truth table as stated in the slide, for example, P and Q is only true if both P and Q are true. In all other cases, the result will be false. So, we move on to the third basic logical connective, which is disjunction. Disjunction joins with 2 statements. It is true if at least one of the statements is true. It's represented by the symbol disjunction or the word or. From the truth table as stated in the slide, for example, if either P or Q is true, then P or Q is also true. Next basic logical connective is conditional. A conditional statement means if one thing is true, then another must be true too. It is represented by an arrow or the phrase if then. From the truth table as stated in the slide, for example, if P is true and Q is false, then P conditional Q is false. In all other cases, it is true. Last but not least, basic logical connective is biconditional. Biconditional means both statements must be true or both must be false for the whole expression to be true. It is represented by if and only if, or simply if for short. Look at the true table as stated in the slide. For example, when both P and Q are true, the result is true. When both P and Q are false, the result is also true. But if one is true and the other is false, the result is false. To conclude, a biconditional means P and Q have the same true value.
Now we're moving on to laws of logic, where we have 12 logics. First thing first, we have double negations, where not P is equivalent to P. Other than that, we also have De Morgan's law, where not P or Q is equivalent to not P and not Q. Otherwise, it's not P and Q is equivalent to not P or not Q. The third one, we have communicative law, where P and Q is equivalent to Q and P, while P or Q is equivalent to Q or P. The fourth one, we have associative law, where P or Q or R is equivalent to P or Q or R, while P and Q and R is equivalent to P and Q and R. The fifth one, we have distributive law, where P and Q or R, P P or Q and R is equivalent to P or Q and P or R, while P and Q or R is equivalent to P and Q or P and R. The sixth one, we have idempotent law, where P or P is equivalent to P and P or P is equivalent to P. Now we're moving on to identity law, where P or contradiction is equal to P, while P and tautology is equivalent to P. Number 8, we have inverse law, where P or not P is equivalent to tautology, while P and not P is equivalent to contradictions. Number 9, we have dominance law, where P or tautology is equivalent to tautology, while P and contradictions is equivalent to contradictions. Number 10, we have absorption law, where P or P and Q is equivalent to P, and P and P or Q is equivalent to P. While number 11, we have definition of implication, where P implies Q is equivalent to not P or Q. And now we are on the 12th one, which is definition of biconditional, where P biconditional with Q is equivalent to P implies Q and Q implies P, while also can be written as not P or Q and not Q or P.
Let's delve into this case study involving 3 propositions. First, P, the athlete passed the fitness test. Second, Q, the athlete has previously participated in a state level championship. The third one is R, the athlete received support from the coach. These propositions will help us see how the laws of logic apply in real-world scenarios. First, notice how these statements are simple yet significant. Each proposition can be evaluated independently, but their relationships reveal deeper insights. As we move forward, we'll use these statements to explore logical implications and see how they can influence decision-making in sports context. Keep these propositions in mind as we build on them in the following slides. From the 3 propositions that we have, we can move on to our first question, which is the one in the slide, P or Q and P or not Q, the whole statement, or Q. So we need to identify which laws of logic that we can use to simplify this statement. For the first one, we can see there are 2 P, so we can use distributive law, which we can combine both of the P's into one since it has the same logical connective, which is OR. So the statement will change into P or Q and not Q, the whole statement, or Q. So after that, we can identify there is Q and not Q. This is contradictory parts can be reduced using inverse logic. So we can use inverse law to reduce Q and not Q into contradictory. So for the last one, when P or contradictory, we will get P using identity law. So our simplified statement is P or Q. It's the athlete passed the fitness test or has previously participated in a state level championship. Moving on to the next question.
Now our question is P implies Q and not Q and R or not Q. First thing first, we use absorption law so that our right side of the equations will only be left with not Q. So now our equation is P implies Q and not Q. After that, we use implications since we have implies. So now we're only left with not P or Q and not Q. After that, we use commutative law to rearrange the equations. So now we have not Q and not P or Q. After that, we use distributive law, and then we will have not Q and not P or not Q and Q. So not Q and Q, we will use inverse law to have contradictions. After that, we use identity law, and our equation now left with not Q and not P. After that, we simplify our equation using De Morgan's law. So our equation now is not Q or P. And that's the answer.
This is the third question, which is P or Q or bracket, not P and not Q and R. So it is equivalent to P or bracket, Q or not P, and Q or not Q, and Q or R. This is used distributive law. After that, we use inverse law and become a P or Q or not P, and tautology and Q or R. After that, we use distributive law, which is we get P or Q or not P, and P or tautology, and P or Q or R. So we move to the next law, which is commutative law, and become a P or not P or Q, and P or tautology, and P or Q or R. After that, dominance law, which is tautology or Q, and P or tautology, and P or Q or R. So next we use again dominance law, which is tautology and P or tautology, and P or Q or R. After that, we use identity law, tautology, and P or Q or R. Then we use again identity law, tautology, and P or Q or R. And lastly, we use again identity law, which is P or Q or R. And that's the final answer. Okay, for the conclusion, in order to master in laws of logic, we need to memorize all laws of logic. There are 12 laws of logic, such as double negation, De Morgan's law, commutative law, associative law, distributive law, idempotent law, identity law, dominance law, inverse law, absorption law, implication, and biconditional. And for the second conclusion is we can apply list of the following of laws, named the laws of logic, to establish the logical equivalent.